Hi everybody. So in today's video, I'm going to be programming a recurrent neural network and I'm going to compare it to a standard neural network. So let's get right to it. So let me go ahead and delete all of this code in here. I don't need it. But what I'm going to have to do is come over here and copy AI. So I'm going to copy the class AI and then I'm going to paste it right here. But I'm going to change the name of AI to RNN AI. So I need to input the number of inputs and the number of outputs and the number of epochs. So that'll be model A equals RNNAI of the length of X, the length of Y, and then I'll do model A dot build parameters, and then model A of X and Y. So now let me come over here to the build parameters, and I'm going to define the same weight. So self.w equals empty list, self.l equals empty list, and self.sl. Oh, wait a minute. rw, rl, and sl, rsl, I mean, empty dictionaries. So I'm going to come over here and do self.rw of I equals numpy.random.random of I minus 1 to I minus 2 dimensions. And we're going to see why in a minute. I'm doing it that way. So this will be self.l, no, sl, no, rl of I equals numpy.zeros of I minus 1. And then self.rsl of I equals numpy.zeros of I minus 1. Okay, so I've got all of these set. So I will come over here now and start to make some changes. So this will be, the first thing I'm going to do is just set the epochs equal to like 3. And then what I'll do is, so we have the last neuron stored. So I'm going to come here and do for I in self dot r axis. Remember the reversed axis. So that way we could take the lowest point. So what I will do is I will call this self dot rl of I is going to equal self dot sl of I transpose multiplied by self dot rw of I plus bias. Um, Actually, I don't know if we need the bias in this portion. Um, yeah, so I'll keep it out. If we need it, I'll bring it back in. So then this is going to be self.rsl of I equals self.sigmoid of self.rl of I. And we're not computing the gradient yet. So now that I have this, um, I have my back propagation process that we coded in the video prior to this. Um, so what I want to do here is do gradient 2 equals empty dictionary. So then for I in self dot axis, this will be error equals delta multiplied by self, no, delta transpose multiplied by self dot rw of I. And let me actually go ahead and break this. Let me go ahead and print error, error, and then break that as well. So now I'll open my terminal and then I'll do python 3 rnn.py. Okay, so the dimensions match. That's good. So let me do delta equals error times self.sigmoid of self.rl of I. Derivative equals true. So now we have the gradients. And let me go ahead and print delta. So now I'm going to run that. Yeah, it's a lot of matrix algebra. Um, okay, so the delta is printed out. So I will come over here and do gradient 2 of I equals delta. And then I'll get rid of these. So what I want to do now is just print gradient of 2. So run it. Okay, so I've got the gradients. They're very small. So now I can come over here and I will do for u in self.axis self.rw of u minus equals gradient 2 of u. Okay, so now that I did that, let me do for error in self.the errors print error. So let's see if this works. Okay, the error is being minimized. Um, I don't know too much yet, but let me back out of that and then come over here and do self.epochs. So yeah, everything is done now. The weights are training everything. That's good. So I will now come here and do model B equals AI of the length of X, length of Y, and then it'll be model B dot build parameters, and then it'll be model B of X and Y. So keep in mind, we're only training like one row of data on this. Like this is a very simplified recurrent neural network. But I'll call this FN, no, RNN equals empty list, FNN equals empty list, and then it'll be for I, J in zip, model A dot the errors, and then model B dot the errors. So this will be RNN dot append, numpy dot mean of I, FNN dot append, numpy dot mean of J. And do I have my plot in here? Yes, I do. Okay, good. So this will be ax.cla, ax.set title, RNN versus FNN, recurrent neural network versus feed-forward network, ax.plot RNN color equals red, label equals RNN, and then ax.plot FNN color equals orange, label equals FNN, and then ax.legend, and then plt.pause. Oh, wait a minute. Hold on, hold on. I forgot. The most important piece of the recurrent neural network is to make it recurrent. But I only have to do that up here. So, I mean up here. So it'll be um, if epoch equals 0, I'll do it like this. Else, I'm feeding it back into it. It's going to be self.l of I equals x.transpose dot dot self.w I plus bias plus self.sl, no, rsl of I dot transpose dot self dot rw of I. So let's see if there's like any error with that. Dimension size 5 is different from size 4. Okay. Um so I believe it's reversed. So this is not a transpose. Let's see. I'm going to match the dimensions. Um so I'll clear that. Okay, that ran. So let me go ahead and uncomment these. Hold on. Let me go back up there though just to double check. So the weights multiplied by the standard layer. Um, yeah, so that way it's like recursive. So let me continue with this. plt.pause 0.1, plt.show. So let's see the results of this. I mean, I actually don't know which one is going to be better than which. Okay, so far the recurrent neural network just went berserk. It seems like there's some curvature in the feed-forward neural network as well. So this is like, it's not supposed to be doing this. Um, let me come up here to the gradient and do plus equals. Yeah, I think this might turn into gradient ascent. So I'll come up over here as well and do plus equals gradient. So now run it. Okay, well, that's how you know you can't just inverse something and it'll work. I know why the recurrent neural networks are not working right now. It's because of the extra weights that are being added in. So, okay, so I'll set that back to that. Um, okay, there has to be a reason why this is. No, the reason is because of the previous weights. So, oh, these might have their own bias. Okay, so if I input bias, let's see what happens. Okay, so the recurrent neural network is showing a little bit of improvement right now. It immediately rose, but it's like coming down. Okay, oh, okay. So yeah, I guess at 100 epochs, um, standard it has a lower error, but it just spiked back up. But that's honestly because of like the extra weight that's being trained. So let me come over down here and set epochs equal to 250. So I'll set both of them as epochs equals epochs. Same thing with here. Epochs equals epochs. So now we could see, okay, so the feed forward network actually started off at a higher point. The recurrent neural network is slightly above. It seems to be curving back upwards. Yeah, they both. Nah, this is a. Well, they're both curving back upwards. Okay, that was weird. Let me go ahead and run it again. Okay, so this time the recurrent neural network went high again, but now as like it trains on the same number of epochs, it's like slowing away. And now the feed forward network is rising in error. Okay, so they're going to go up to, yeah, the feed forward network is now not doing so good. Even though it had like a closer convergence, the more epochs, like it just spikes up in error. Let me do that one more time and I'll close the video. So the recurrent neural network starts off really high in error, um, but this time it seems like it's not converging. Yeah, so in this run, the feed forward network performs better. Um, so yeah, that was okay. Let me go ahead and run it one more time. Um, okay, so the recurrent neural network. Okay, so it has the same behavior, how it just spikes up in the beginning, but then by the 50th, the 60th epoch, it just like slows down. But are we going to see the same thing again here, where like the feed forward error neural network like rises in error? Maybe not. But they have their differences. So we could tell like certain they're meant for specific things. You know what? I'll just run it again. Why not? Just like keep it running. Okay, so just spikes up and then same thing, converges. But we saw that previous example where the feed forward network just increased in curvature. So, I mean, to be honest, like getting a model to train on a set of data, it looks the same right here. You know what? I'll set this to 300 and I'll change some of the inputs around. So I'll make this, uh, let me put these to decimals. So 0.11, 0.33, 0.33, 0.41, 0.05, 0.03, 0.6, and then let me change these outputs to 15. Let me give them the same outputs. So let's see what happens to these. So, okay, so the recurrent neural network immediately converges on that run, um, while feed forward is still so now they're reversed. Now that I changed the numbers, it's interesting how they're like different. Um, but yeah, the feed forward neural network is slowly learning, but its error is not being minimized while the recurrent neural network is already at 0. So yeah, so that's the power of the recurrent neural network if you program it right. Like I had a struggle right now doing this, but it ended up working out. So yeah, I thank you all for watching my video. I'm gonna keep coming out with more and more good machine learning content, so stay tuned and peace out.